Hello friends, welcome to EC Academy. In this lecture, let us understand the CMOSC fabrication process. Here, the CMOSC fabrication process is simply an enhancement or improved version of the older PWEL CMOS technology. You just imagine this as the upgraded version of older PWEL CMOS technology. The basic idea of both these technologies are same, but the new version, which is CMOSC technology, works much better compared to older version. Now let us understand some key features of CMOSC process. There are four main key features of CMOSC process. Let us understand one by one. The first feature is boron implantation. So to make the P transistors, we put a chemical element called as boron. So we'll implant this boron during the CMOSC fabrication process. The next process is phosphorus implantation. Similar to how we have boron implantation, we have phosphorus implantation to make n-channel transistors. It is very simple. Boron is used for p-channel transistors and phosphorus is used for n-channel transistors. The next process is lateral diffusion control. In older version of chip design, the electrical current used to leak sideways, which is known as lateral diffusion. The CMOS process has improved control over this lateral diffusion that will reduce the leakage current inside the transistors. The last process is advanced oxide processing. Sometimes while making the chip, the layers will get too thin, as you can see in this diagram. This thinning of the layer will happen exactly at the corner and it starts looking exactly like beak of a bird. So the CMOSC fabrication process uses enhanced field oxide processing to minimize this effect. So the bird's beak problem is solved. Now let us understand the step-by-step CMOSC fabrication process. The first step is the base. We start with a plain base which is known as n-substrate, and on the top of this we put a thin oxide layer and a material known as silicon nitrate. This will form our first foundation. The second step is high energy boron implant. After the foundation, we cover some part with protective mask known as photoresist. Then we shoot high energy boron into the base and this will create the P well inside the N substrate. This step is very important to set the threshold voltage of the N channel device. Threshold voltage, which is nothing but the starting voltage of N channel device. The next step is low energy boron implant. After high energy boron implant, which will form the P well, will perform a low energy boron implant on the top of that layer. This low energy boron implant will help in formation of P well body. The next step is growing thick oxide. After formation of P well and its body, we grow a thick oxide which is also known as field oxide. This is used to separate the different part of the chip safely. The next step is formation of polysilicon gate. In this step, we replace a layer of polysilicon to create a polysilicon gate as shown in this figure. These gates will act as switches that will turn on and turn off the transistors. The next step is formation of source and drain. To make the connections where current enters and leaves, we use boron and phosphorus implant over the photoresist mask to form P plus and N plus layer. So to get the N plus layer, we'll apply photoresist layer and implant the phosphorus, and to get P plus layer, we'll apply a photoresist layer above the P well and then we'll implant the boron. So there will be formation of N plus and P plus layer. So this will act as a source and drain. The last step is final connection. Finally, we cover with a protective layer called as CVD oxide. Then we add aluminum metal on the top to connect everything together. Adding aluminum metal is just like doing final electrical wiring. So finally summarizing the things, we understood that CMOSC is an advanced and improved P-well CMOS technology. Here we use boron for P-channel transistors and phosphorus for N-channel transistors. This technology reduces the leakage current and minimizes the bird's beak shape by using enhanced field oxide processing. Here we use different steps on n-substrate to create P-well. Then we add polysilicon gate, and finally we connect it with aluminum wiring. So finally this is the HP chip designed using CMOS process, where boron is used for P channel junctions, phosphorus is used for N channel junctions, and it will control the leakage current, and also it reduces the bird's beak. This is about CMOSC fabrication process. Hope you have understood the topic. Thank you.